Hi, I'm Brian Malow, and I'm speaking with Ryan Kingsbury. He's a postdoc at Berkeley and one of the 12 finalists in this fourth annual Research SLAM. So Ryan, thanks for taking the time to speak with me today.
Pleasure to be here.
And this is the fourth annual Research SLAM. Have you done it before?
No, I have not. This is my first one.
How are you feeling about it? Are you nervous?
Excited.
Are you excited?
Well, mostly excited. I really enjoy the challenge of, explaining things in simple terms.
Yeah, and you know what? I want to come back to this and ask you about outreach, but maybe first let's talk a little bit about your research and what do you identify as? What kind of scientist are you?
Well, first and foremost, I would call myself an engineer, and I've become more and more of a scientist over the years as I've sort of followed my curiosity about solving problems. My specialty is in water treatment, so studied special filtration materials and other processes for filtering drinking water and treating waste and that sort of thing.
Do you have a succinct way of that, like differentiating between a scientist and an engineer?
Well, the joke that I've heard is a scientist is thrilled if something works one time, and an engineer is terrified if something doesn't work one time. So there's an aspect of practical solutions versus kind of one-off curiosity-driven problems. I don't know.
And did you always know where are you from?
Houston.
Houston. I grew up in Houston. And did you always know you wanted to be in the sciences? And in this kind of field of it, or maybe you had some other interests? Were you ever headed towards another career?
I think I always knew I wanted to do something technical. When I was little, I was always helping my dad fix stuff around the house and building with Legos, and I knew I wanted to build stuff in some form or another. So I think I was always headed towards science or engineering.
Excellent. And tell me about, you grew up in Houston. Tell me where you did your undergrad and especially graduate work. What was the path to Berkeley?
Yeah, I've had a rather convoluted path to Berkeley. I went to UT Austin for undergrad, studied civil engineering, and I got really interested in water treatment. I went to work for a short period and realized that I wanted a master's degree because everybody around me had one. So I went to University of North Carolina to get a master's degree. Did that for a couple of years, went back to work again, and worked in water treatment infrastructure for a while. And then my scientific curiosity kind of got the better of me, and I got a little bit bored with what I was doing. And so I took a couple of years. I actually started a little company to research technology, and then that led me into a PhD. And then after the PhD, it was time to come to Berkeley to learn some new skills as a postdoc.
That's excellent. UNC, which school in North? I'm here in Raleigh right now.
Oh yeah, Chapel Hill.
Chapel Hill. Okay, UNC Chapel Hill. Excellent. And so, what are you working on now? You're a postdoc at Berkeley. You're in the energy technologies area. Energy storage and distributed resources is even more specific. What is it you're working on? And I'm intrigued by the title of your talk, "If the Shoe Fits."
Yeah, so I study these special sort of filtration materials that are designed to separate charged particles called ions. So this ability to filter different kinds of ions from water is something that is important to all kinds of different technologies, from the battery in your phone to different kinds of water purification or water desalination processes, even to recycling some really critical materials that we need for modern devices and electronics. It all comes down to these really tiny dissolved particles that carry a charge, and they're really hard to separate from each other. So it's a real materials design challenge.
It sounds like a job for a physicist. It sounds like you're talking a lot of physics here.
Yeah, well, one of the things I love to say about what I do is it's in this kind of gray area between engineering and chemistry and material science and polymer science. So I came at this from the engineering direction, but what I do now is a sort of a blend of a bunch of different disciplines, I would say.
And maybe more specifically, what is "If the Shoe Fits"? What is your talk going to be about?
Yeah, so one of the ways that we can go about filtering these charged particles I'm talking about is by making a sort of shoe that fits them really, really precisely, so that it can grab onto the one that you want and not accidentally grab onto one that you don't.
Interesting. And so, help me understand again the bigger picture, that like the applications of this, because you're down to the nitty gritty, like, okay, what's happening biochemically, but but what's the big picture? What's the need for this?
Yeah, well, so I'll give you an example from your phone battery, right? You've probably heard the term lithium-ion battery, right? That's what's in phones and cars and laptops and everything else. And they're called that because what happens inside that battery is these little charged particles, lithium ions, swim back and forth between two sides of the battery, and that's what causes, that's what creates the power, essentially. And so you can imagine lithium is becoming a hot commodity, and it's very important for modern manufacturing, and it's not mined too many places in the world. So there is lithium in the ocean, in groundwater, here in California even. And if we can extract that economically, we can develop these new sources of this really important material and not be so reliant on just a small handful of mining operations. That's just one example. There are many others. But.
Sure. And it's what gets you up every day? What motivates you to get up and go to the lab and do the kind of work you do? Is it just cool science that you like doing, or do you have some other motivate? Are you trying to make a difference, or what actually is it?
Well, a little of both. I mean, certainly there's a lot of just raw scientific curiosity. This problem of, how do we separate one kind of ion from another is just a really fascinating puzzle to me that I just love to think about and love to investigate. At the same time, it does certainly tie into making a difference. I mean, I certainly view climate change as the grand challenge of my generation. And like I said a minute ago, I think this problem of these ion separations is something that arises in a bunch of clean technologies. So we have all sorts of emerging green technologies that are kind of held back by not being able to do a very good job with this filtration piece. And so I really do believe that if we advance this area of science, we have the potential to advance a lot of important technologies.
Excellent. So in addition, I'm always fascinated when scientists do outreach, because your research itself is a full-time job, but then doing things like the Research SLAM are outreach. Do you engage in other outreach? Do you feel that it's important for you as a scientist to engage in public outreach?
Yeah, I think it is. Probably now more than ever. I think people need to understand what scientists do and how we approach problems. So personally, I've engaged in quite a bit of K through 12 outreach, just to encourage more and more kids to pursue STEM careers. So that's something that's a lot of fun. We have a couple of really great new programs at Berkeley Lab specifically that give high school students, for example, a chance to come and engage with lab scientists over an extended period during the summer. So that's been one thing I've participated in.
Excellent. Well, I want to thank you for taking the time. It's like you're one of the 12 finalists here. We're coming up on the SLAM. I want to thank you for taking the time to talk to me, and just good luck in the SLAM.
Thank you. My pleasure.